Hi, my name is Apurva Manaraj. For my project, I chose a problem I've encountered working in the banking industry, predicting when an ATM will run low on cash and need replenishment. Today, banks often schedule ATM cash replenishments at fixed intervals or rely on manual judgment. This can either lead to cash outs where customers find the ATM empty or excessive cash sitting idle in the machines, which has high cost and security risks. I think this is a great opportunity for machine learning because first, there is a clear problem, optimizing cash levels in the ATMs. Second, machine learning can help by predicting cash out risks based on historical withdrawal patterns, location trends, day of the week effects, and events like festivals. Third, this matters to the stakeholders. It improves customer satisfaction, reduces operational costs, and lowers working capital requirements for banks. Using the CRISP DM framework, let me define the business understanding. The target users are ideally cash management teams and operation managers in the banks. What the problem statement is, we want to predict the likelihood that an ATM will run low on cash within the next 48 hours. So the operations team can proactively schedule replenishments. Why does it actually matter? Running out of cash damages customer trust and brand reputation, and keeping too much cash idle costs the bank in terms of cash handling and security risks. How is it solved today? Many banks follow fixed replenishment schedules or rely on operational experience rather than data driven decisions. What would the actual business impact be? It would lead to fewer cash outs, reduced emergency replenishment costs, and better cash utilization. The outcome metrics: reduction in emergency replenishments and cash out, for example, as a percentage drop in cash outs. The output metrics: model performance can be measured using classification metrics like precision and recall for predicting cash out risk. There has to be certain constraints. The model needs to generate predictions at least 24 to 48 hours in advance and maintain high accuracy to avoid false alarms. My solution concept is to train a machine learning model that forecasts the likelihood of an ATM running low on cash based on transaction data, seasonal trends, and external events. To validate this solution, I take an iterative experimentation approach. Start by creating mockups or dashboards showing how cash out risk predictions would look like for the operations team. Share these mockups with users to get feedback on usability and interpretability. Build a simple prototype using historical data, even if only using heuristics at first, to see if predictions align with real world observations. Incorporate user feedback and retrain the model to improve precision and reduce false positives. For the machine learning system design, for cloud versus edge, I deploy the system in the cloud. Banks already operate large centralized systems, and a cloud deployment allows easier scaling, model updates, and integration with other bank systems. For online versus offline learning, I'd choose offline learning. This model doesn't need minute by minute retraining. Instead, I'd retrain it monthly or quarterly using fresh data to capture new withdrawal patterns. For batch versus online predictions, I generate the predictions in batch mode daily. Operations team typically plan replenishments once per day, so near real-time predictions are not essential. In production, there are several risks I'd consider. Data drift: people's cash usage patterns can change, for example, during festivals or economic disruptions. Monitoring drift in withdrawal patterns is critical. Concept drift: if new usage patterns emerge, such as shifts towards digital payments reducing cash demand, the relationship between features and cash out risk could change. Training serving skew: ensuring that the same data processing steps used in training are applied during live prediction is essential to avoid this skew. Latency: fortunately, since we are doing batch predictions, latency is not a major concern. To mitigate these, I'd set up monitoring dashboards for input data distribution and prediction outputs. Define threshold that trigger retraining when drift is detected. Maintain version control on both models and data pipelines. In summary, Predicting ATM cash replenishment needs using machine learning is a valuable opportunity to save costs and improve customer service. With a solid validation plan, a cloud-based architecture, and a strong monitoring system, this solution can successfully be implemented and maintained over time. Thank you for listening.